Intermediate Algebra for Statistics. Factoring trinomials of the form x squared plus bx plus c and differences of two squares. Part 2. Lesson objectives. Factor a trinomial of the form x squared plus bx plus c. Factor a difference of two squares. Example 5. Factor a squared plus 6ab plus 8b squared. Solution. We need two monomials whose product is 8b squared and whose sum is 6b. 2b times 4b multiply to give me 8b squared, and 2b plus 4b gives me a sum of 6b. We can check this by using the distributive property. A times a is a squared. A times 4b is 4ab. 2b times a is 2ab. And 2b times 4b is 8b squared. Combining like terms, and we have a value for the middle term to be equal to 6ab. It checks. Prime polynomials. Definition. A polynomial that cannot be factored is called prime. This is just like a prime number, say 7. 7 cannot be factored by any other number except 1 and 7. So any polynomial that cannot be factored is called prime. Example 6. Factor negative 14 plus 6x plus x squared. In this case, our c is negative 14, so the factors will have a different sign, and they should add up to give us a positive 6. Solution. So the product pairs of negative 14 are 1 and negative 14, 2 and negative 7, 7 and negative 2, and 14 and negative 1. But none of these pairs add up to give you 6. Therefore, this trinomial is prime. Lesson objective. The difference of two squares. Property. A squared minus b squared equals the binomial a plus b times a minus b. In words, the difference of the squares of two terms is the product of the sum of the terms and the difference of the terms. The way I think of it is, if we have a perfect square minus another perfect square, that is equal to the square root of the first term plus the square root of the second term times its conjugate. Let's do an example. Example 7. Factor number 1, x squared minus 49, and number 2, 36w squared minus 25y squared. X squared is a perfect square. We have subtraction, and 49 is a perfect square. 7 times 7. So since x squared minus 49 can be written x quantity squared minus 7 quantity squared, we can say x squared minus 49 is equal to x plus 7 times x minus 7. Now we can verify this by fulling this out. X times x is x squared. X times negative 7 is negative 7x. 7 times x is positive 7x. The two terms cancel, and then we have 7 times negative 7, which is a negative 49. It checks. Number 2, 36w squared is a perfect square minus 25y squared. That's a perfect square. So we can write this as 6w quantity squared minus 5y quantity squared, and we will have 6w plus 5y times the quantity 6w minus 5y. Example 8. Factor A, p squared minus 64, b, 121 minus y squared, c, x squared minus 36 y squared, d, x minus 2 quantity squared minus 49. A, this is a perfect square minus another perfect square, so it factors to p plus 8 times p minus 8. B, 121 is a perfect square, so is y squared. Square root of 121 is 11, so we have 11 plus y times 11 minus y. C, perfect square minus perfect square. Square root of x squared is x. Square root of 36y squared is 6y. So applying our formula, this factors to x plus 6y times x minus 6y. And again, we can pull this out to verify. This is a perfect square minus another perfect square. The square root of x minus 2 quantity squared is x minus 2, and the square root of 49 is 7. Therefore, we can write this as x minus 2 plus 7 times the conjugate of that, which is x minus 2 minus 7. Since these are like terms, we can combine them, and we have x plus 5 times x minus 9. Common mistake. A squared plus b squared does not factor. Only a squared minus b squared factors, and it factors into a plus b times a minus b. Thanks for watching.